So I'm going to organize this slightly differently than the previous speakers. We have 4 principal investigators in our group, Marie Kievsky, myself, Mie Park, and Arek Šitek. And I'll talk about what each of them have been working on very quickly. Marie's been working on 2 projects that might benefit from collaboration with this group. One is to determine the limits on absolute quantitation of activity concentration distributions in brain and prostate tumors. The significance is that traditional open brain surgery, non-invasive image-guided ablation, and targeted drug delivery through the blood-brain barrier depend critically on correct definition of tumor distributions. And a research opportunity on this project is to evaluate standard and novel reconstruction algorithms, investigate the bias of point spread function incorporating high-res approaches. She's also working on a dedicated cardiac SPECT imaging system comparison rather than general systems, to evaluate several devices, one of which we have and another we're probably going to be getting soon, for quantitative imaging tasks using both phantom and clinical data. The significance is that high sensitivity dedicated systems are expected to lead to improved performance in imaging myocardial tracers, particularly for those with rapid kinetics in dynamic scans. And of course, there's research opportunities always to acquire and analyze phantom data and eventually human studies. I have 2 projects that might be useful for collaboration. One is to correct for partial volume and tissue spillover effects in multimodality imaging, SPECT-CT, PET-CT, etc. Our approach uses the key features of both modalities to enable a physician to obtain accurate and precise estimates of activity concentration in a few local tissues surrounding a tumor or lesion of interest. And here we need help in developing semi-automated local dual modality image segmentation software and interfaces to imaging system vendors' image reconstruction software. Another project, we're developing improved iterative techniques for reconstructing Bremsstrahlung photons emitted by beta particle scattering. Bremsstrahlung imaging can be used for dosimetry calculations following intra-arterial injection of yttrium-90 microspheres for radioembolization of hepatic tumors, as well as for imaging of neuroendocrine tumors during radionuclide therapy. And we need reconstruction algorithm development and validation with phantom and human studies. Mie Park's been working on positron-guided surgery using an intraoperative positron probe system to maximize tumor resection after injection of a PET tracer, and to test novel PET tracers from our Brigham and Women's Hospital cyclotron. We need help here evaluating an integrated system with tracking, navigation, positron probe, and software in a clinical trial and comparisons with MRI-guided surgery. Another project was to develop brain SPECT imaging with very high sensitivity collimation. The count sensitivity from the center of the brain is about, with the collimator she's designed, is about 10 times higher than that of conventional collimation. Should be useful for diagnosis and management of a number of neurologic diseases. We have the new collimator, which has just arrived at the Brigham, and we need a lot of work testing it and so on. And finally, Arek Šitek, who's in the 5th row on the back there, if anyone wants to talk to him, has a few projects, one involving statistical analysis of emission tomographic data, to investigate estimation and classification tasks using conditional statistics. Another project is quantitative imaging in SPECT and PET. And the third project, I'm getting booted here, so the third project is use of brain computing in radiology, and I'll leave the slide up. You can read the details. Okay?
Very good. Thanks, Dave.
Thanks.
Yes.